continue straight from last video where we calculate the force in compression steel CS 600 kilonewton. Now we like to calculate the force in the tensile steel. So first we calculate the strain in the tensile reinforcement. Again we're going to use a similar triangle method where EST is drawn here, the small line here, which is the strain in the tensile strain in the tensile reinforcement over 0.03, similar to here where we draw this horizontal line, horizontal distance over horizontal distance, equal to this small distance is given 74. If you go back to our examples, we have 74 distance given here, so that little distance here 74 over 600, that's total depth. So EST will be given calculated here 0.00037. Now this is a different because your EST value is less than ESY. This 0.037 that we calculated, which is less than your Young modulus. So the steel here, it's not yielded, so we can't use this 500 megapascals. It's not more than that. So in that case we need to calculate the stress in the tensile steel. The stress is equal to strain times Young modulus, and we found the strain is 0.00037 times 200,000, so it's given 74 megapascals. Now if you know the stress, then you can calculate the force in the tensile. Stress is equal to stress times area. So stress was 74 times the area of the steel reinforcement is given 1200 millimeter square. So I substitute that 1200 millimeter square, it gives me 88,800 newtons, and divide by thousands gives me 88.8 kilonewton. We're going to use 89 kilonewton as a round numbers. So if I just want to calculate the force acting on the sections, like what would be the force in the decompression point, so we are just wants to find out what would be the force here at point B, because we need to get this point B. So NU at point B, that's I calculated here. Now that NU is just the sum of all your forces that we calculated. So sum of the forces, meaning that we have this force in the compression of the steel, we have this force in the concrete, and we have this force in the tension, all the compression forces. So compression force in the concrete is 5784 kilonewtons, plus compression force in the steel is 600 kilonewtons. We have calculated that in the last video. And compression force in the tensile reinforcement is we calculated just now, that is 89 kilonewtons. So I just use 89 kilonewtons here, that will give you this number 6483 kilonewtons. So this is the force that we need to use here in the plotting this one. So you have this force here at point B. If you draw the line here, this force is this 6483. Now we need to calculate the moment, right? We need to know what moment. So to locate these points, we need the moment and we need the force. We found the force. Now let's calculate the moment. Now to calculate the moments, we will just draw this force in the steel, take force in the compression steel, force in the tensile steels, and this is the force in the concrete. Please note this force in the concrete will act at the half of this gamma KUD, and KU is equal to 1, so gamma D divided by 2, so that is at the center of this stress block. So I draw this figure here, which is compression force CS. We calculated 600 kilonewtons. Compression force in the concrete we have calculated 5784, and the compression force in the tension reinforcement that we calculated 89 kilonewtons. Now the distance, this is a plastic centroid. Plastic centroid is sitting here because this is a symmetric section, so we have plastic centroid at the half. I think I will put one more videos where where we going to look at the plastic centroid calculations, but here the calculation is very simple here because it's a symmetric, because if you have 1200 here, 1200 here, so the plastic centroid would be located at the half, which is half of 600 would be 300. So I draw this plastic centroid at 300. This distance here 74, that is given in our example, that is 74 at this distance. 300, 526, that distance is given in the example 74, so 600 take away 74 give us this 526. This distance gamma D divided by 2, gamma we calculated in this one here 0.87 times 526, that the depth of the reinforcement, that D over 2 give me 229, that is this distance 229. The calculation of the plastic centroid calculation of the moment we will look at in the next video. Thank you.